Hello friends, welcome to SSP Math. Today we are going to start new topic, that is orthogonality, orthogonal and orthonormal set. Okay. So in last video we already learned inner product spaces. Means how to find inner product of U and V, then norm, length. Okay. So today we will see about orthogonality, orthogonal and orthonormal set. So what do you mean by orthogonality? Let V be an inner product space. Two vectors uv belongs to V are said to be orthogonal if inner product of uv equal to 0. So when we say that u and v are orthogonal if inner product of uv equal to 0, means if we get inner product of uv equal to 0, then we can say that u and v are orthogonal. Now here some problems are given. So first problem is check whether the following vectors are orthogonal or not. So in which first one is given u is equal to 1 1 1, v equal to 1 2 minus 3. So we will check one by one here. So first we have to find inner product of u and v. Okay, so this one. So inner product of u and v is equal to 1 into 1 plus 1 into 2 plus 1 into minus 3. And if we solve this, this is 1 plus 2 minus 3. This 1 plus 2 is 3 and 3 minus 3 is 0. So inner product of uv equal to 0, and therefore we can say that u and v are orthogonal. Okay, then second one, how to solve second? For solving second problem we have to find again inner product of u and v. So inner product of uv is equal to this one, that is 1 into 1 plus 1 into minus 4 and plus 1 into 3. So what is this? This is 1 minus 4 plus 3. This 3 plus 1 is 4. 4 minus 4 is equal to 0. So here also inner product of uv equal to 0. So we can say that u and v are orthogonal. But if we check here third one means this one, then here inner product of u and v is not 0, I think. See here 1 into 1 is 1 plus minus 4 into 2 and plus 3 into minus 3. So what is this? This is 1 minus 8 minus 9. Minus 8 minus 9 is minus 17. So 1 minus 17 is equal to minus 16. Minus 16 means this is not equal to 0, and therefore u and v are not orthogonal. So this is related to orthogonality. Now next topic of our syllabus is orthogonal and orthonormal set. So when we say that given set is orthogonal, or when we say that given set is orthonormal set. Okay, now if we consider here set S is equal to u1 u2 up to so on un of non-zero vectors in an inner product space V. So S is called orthogonal if each pair of vector in S are orthogonal. So when we say that this set S is orthogonal set if each pair of vector in S are orthogonal. For example, here u1 and u2 are two vectors, say. So if we find inner product of u1 and u2, and if we get that inner product is equal to 0, then we can say that u1 and u2 are orthogonal. Similarly, we can find inner product of u2, u3, u3, u4 and so on. If each inner product is 0, then we can say that that set S is an orthogonal set. And when we say that S is orthonormal set, means S is called orthonormal if first S is orthogonal and each vector in S has a unit length. Means for example, u1 is the vector of S, has unit length, means if we find unit vector of u1 and if we find its norm, that norm should be 1, then we can say that. Means similarly we can check each length of each vector, that length should be 1, and first S is orthogonal set, then we can say that S is orthonormal set. So one remark is given, if S is orthogonal set of non-zero vectors, then S is linearly independent. Okay, now next one is one problem here. Find unit vector orthogonal to u is equal to 1 1 2 and v equal to 0 1 3 in R3. So problem is very simple and important and logical problem. So we have to find unit vector here. Okay, and that unit vector orthogonal to given two vectors. Given vectors are u equal to 1 1 2 and v equal to 0 1 3. Suppose if we assume that unit vector is say w, means if we suppose take w is equal to x y z is unit vector orthogonal to u and v, means if w is orthogonal to u and v, then inner product of w u equal to 0, that is this. And if we take inner product of w u equal to 0, inner product of w u, how we find? W is x y z and u is 1 1 2. Its inner product equate with 0, then we get this equation, that is 1 into x plus 1 into y plus 2 into z equal to 0. Then also w is orthogonal to v. Okay, if w is orthogonal to v, then inner product of wv is also 0. Okay, and if inner product of wv equal to 0, then w is xyz and v equal to 0 1 3. So 0 into x plus 1 into y plus 3 into z equal to 0. Okay, using these two conditions we will get these two equations. Okay, now we have to find unit vector. Unit vector means we have to find vector w. So how to find vector w? So for that we have to solve equation 1 and 2. And equation 1 and 2, these are the two equations in three unknowns. How to solve? Using Cramer's rule. So what is Cramer's rule? X upon determinant of coefficient of y and z from first equation is 1 2, from second equation is 1 3. Okay, equal to minus y upon coefficient of x and z from first equation is 1 2 and from second equation is 0 3, and equal to z upon coefficient of x and y from first equation is 1 1, from second equation is 0 1. Okay, and if we expand these determinants, then we will get x upon, see here, 3 minus 2 is 1, equal to minus y upon 3 and equal to z upon 1, means x equal to 1, y equal to minus 3, z equal to 1. X equal to 1, y equal to minus 3, z equal to 1. So these are the values of x, y, z. Okay, and what is our question? Our question is find unit vector orthogonal to u and v, and वो unit vector हमने क्या assume किया था? W equal to x, y, z, and therefore the value of x is 1, value of y is minus 3, value of z is 1. So 1 minus 3 1 means w is equal to 1 minus 3 1 is the unit vector orthogonal to given two vectors. Okay, then next problem is show that S is orthogonal set. How to show that here? S is orthogonal set where S is equal to u v w, and u is given that 1 2 minus 3 4, v equal to 3 4 1 minus 2, w equal to 3 minus 2 1 1. Also obtain orthonormal set from S. Okay, so first we have to show that here S is orthogonal set. देखो इस क्वेश्चन में यदि ऐसा पूछा होता डायरेक्टली फाइंड ऑर्थोनॉर्मल सेट और ऑब्टेन orthonormal set from given set of vectors or from given vectors, then first we have to check that S is orthogonal set or not, because for orthonormal set first that set should be orthogonal. So here our question is show that S is orthogonal set. So when we say that S is orthogonal set, if each pair of vector in S is orthogonal, so in S there are three vectors, u is given, v is given and w is given. So we have to find inner product of each pair of vector, means first if you find inner product of uv, okay, so inner product of uv is equal to क्या आएगा 1 into 3 plus 2 into 4 plus minus 3 into 1 and plus 4 into minus 2. So this is equal to 3 plus 8 minus 3 minus 8 equal to 0. 8 get cancelled, 3 get cancelled. So inner product of uv equal to 0. Similarly, if we find inner product of vw, so inner product of vw means these two. Okay, so that is 3 into 3 plus 4 into minus 2 plus 1 into 1 and plus minus 2 into 1. So what is this? This is 9 minus 8 plus 1 minus 2. So this minus 8 minus 2 minus 10 and 9 plus 1 is plus 10. This is also 0. Similarly, we have to find inner product of uw. So inner product of uw is also 0 here, and therefore you check this inner product of uw वो भी 0 ही आता है. Okay, and therefore we can say that set S is an orthogonal set. Okay, so first part is over here. Show that S is an orthogonal set. Now second part is also obtain orthonormal set from S. Now here S is orthogonal set, so we have to find orthonormal set of S. For that, normalize each vector of S. Means first we have to find norm of U. And how we find norm of U? Norm of U is equal to under root of, suppose a1 a2 a3, then a1 square plus a2 square plus a3 square. So norm of U is equal to, U is this. Okay, so 1 square is 1 plus is 2 का square आएगा 4 plus minus 3 square is 9 and plus 4 square is 16. So what is this? This is equal to 16 plus 9 25, 25 plus 4 plus 1, that is 30. Okay, so norm of U is equal to 30. Similarly, find norm of V. Norm of V यदि find किया तो वो आएगा is equal to square root of V is this. 3 square is 9 plus 4 square is 16 plus 1 square is 1 plus minus 2 square is 4 is equal to under root of 16 plus 4 20 and 20 plus this 9 plus 1 is 10, that is also 30. Okay, and norm of W, if you find here that norm of W is this vector. 3 square is 9 plus 2 minus 2 square is 4 plus 1 plus 1. So this is 9 plus 4 13, 13 plus 2 is 15, so root 15. Okay, so these are the norm of each vector of S. Now we have to find unit vector. So how we find unit vector? So here we get norm of U is equal to root 30. Okay, norm of V is also root 30 and norm of W is equal to root 15. Okay, now we have to find unit vector, that is U cap is equal to U bar upon norm of U bar. Okay, U cap is equal to U upon norm of U is equal to, now what is U? U vector is 1 2 minus 3 4 and norm U is 1 root 30. So this is 1 by root 30 comma 2 by root 30, then minus 3 by root 30 and 4 by root 30. Similarly, you can find unit vector V cap is equal to, by taking V upon norm V, and W cap is equal to W upon norm W. Okay, so after getting these three unit vectors, if we find norm of each unit vector, that norm is 1 here, and therefore how we write then orthonormal set, and therefore orthonormal set is equal to orthonormal set S is equal to U cap V cap W cap. Means for orthonormal set, first we have to check whether that set is orthogonal or not. If that set is orthogonal, then find norm of each vector, and from that find unit vector of that vectors and write that unit vectors in set S, that S is called as orthonormal set. Thank you. In next video we will start Gram-Schmidt orthogonalization process. So thank you.